Lesson 4.8, Modeling Launched Objects. If you recall from Lesson 4.5, we had a formula or a model for dropped objects on Earth. The model for launched or thrown objects is similar, and it's listed here. H equals negative 16t squared plus v sub 0t plus h sub 0. H is our height as it was before. T is our time in seconds as it was before. We now have a v sub 0, which is our initial velocity. Remember, anything with that sub 0 means initial. And h sub 0 is our initial height as it was before. So looking at this first example, a juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground and has an initial velocity of 40 feet per second. The juggler catches the ball when it falls back to a height of 3 feet. How long is the ball in the air? So again, we know we're going to be solving for t because we want to know how long the ball is in the air. When we plug in here, the final height is going to be 3 feet because that's where the juggler catches it. We have the negative 16 t squared plus our initial velocity is 40 feet per second and our initial height is 4 feet. To solve this, we're going to use the quadratic formula. So the first thing we have to do is set it equal to 0. I'm going to move everything to the left side of the equation so that my a is positive. That gives me positive 16t squared minus 40t minus 1 equals 0. From here, we will plug it into the quadratic formula, and we will have x equals 40 plus or minus the square root of negative 40 squared minus 4 times 16 times negative 1 all over 2 times 16. That's going to give me x equals 40 plus or minus the square root of, when I plug all of this into the calculator, I'm going to get 1,664 over negative 32. At this point, I'm simply going to plug it into my calculator and come up with a decimal answer, because we know that an answer in radical form isn't going to make much sense to the average person. So we're going to say x equals, plug the entire thing, make sure we get our 2 solutions into our calculator, and we will have one solution is approximately negative 0.025, and the other solution is approximately 2.5. The only one that makes sense, of course, is the positive solution of about 2.5 seconds.